This is question 4, the free response from AP Classroom. Part D, I was asked to explain this. Let y equals f of x be a function defined implicitly by this little rascal. It's continuous on the closed interval from 2 to 2.1, differentiable in the open interval from 2 to 2.1 non-inclusive. Use the mean value theorem on the interval to show that this is true. Since it tells us that this is continuous and differentiable, then we can use the mean value theorem, which says there must be a value of c in which the instantaneous rate of change equals the average rate of change. So this is the catalyst for the problem, knowing that we're trying to get to this point. So what looks familiar about this is that the middle of this is this numerator. This says from stem of problem, if you go back to what this problem originally said, here this is the stem. It tells us that the derivative is between 2 and 2/3. So if I just take this, copy it, and bring it down here so you can see, that's what I just wrote here in the middle. This is saying the same thing as this. And we're saying that f prime of x, or f prime of c, is equal to this. So that means I can replace this with this and get this inequality right here. Once I have this inequality, what I'm trying to accomplish is I want it to look exactly like this. If I'm dividing by 1/10, that's the same as multiplying by 10. Or you could say I'm going to multiply this by 1 in the form of 10 over 10. These would cancel, and we would get this 10 on the top. If you then, because we're trying to get this by itself, because that's how it is up here, if you divide all three terms by 10, which is the same as multiplying by 1/10, it's going to cancel in the middle. We get 2/3 times a tenth on the left, 2 times 10 times 1/10 on the right. This simplifies to 1/15. This simplifies to 1/5. And now this is exactly what this is. So we use the mean value theorem right here, and we showed that this is true by working out this algebraically to get to this point.